Welcome incoming CS 101 students. So you've probably got this PDF file, your course syllabus, just sitting right there on your desktop. Consider this explainer your ultimate master blueprint for completely unpacking that document. Today, we're going to transform that static PDF into a clear, actionable roadmap for your entire semester. Whether you've been tinkering with code for years or, you've literally never written a single line, you are in exactly the right place. We're going to break down the sheer power of the tool you're about to master and really look at how this specific course is going to completely rewire the way you solve problems. All right, scanning through this document, here's our agenda for today. We've got 1. Welcome to C++ programming. 2. The logic of coding. 3. Syntax and data types. And finally, 4. Course logistics and expectations. Okay, let's jump right into Section 1. Welcome to C++ programming and software development. Now, before we look at any actual code or start stressing about grading, we have to pause and ask the most fundamental question to demystify what you'll actually be doing this semester. What exactly is programming? I know, it sounds intimidating, almost like some sort of arcane, impenetrable magic, but the reality is actually incredibly practical. Well, looking at the syllabus definition here, programming is just the process of creating precise instructions that tell a computer how to perform complex tasks and solve problems. So the absolute crucial point here is that you are simply learning how to give incredibly specific step-by-step directions to a machine. Think of a computer as the most powerful yet intensely literal-minded assistant you'll ever have. I mean, it can calculate the trajectory of a rocket in milliseconds, but it doesn't inherently know how to do anything unless you tell it exactly what to do. Programming is just the language you use to communicate those instructions. The document lays out a few core goals for us. Beyond just memorizing commands, you're going to understand core programming fundamentals, develop systematic problem-solving skills, craft efficient C++ programs, and ultimately apply that logical thinking to real-world scenarios. This course isn't just teaching you how to type, it's literally teaching you how to think. Now, you might be wondering why C++? Why not Python or JavaScript, right? Well, you are learning a general-purpose powerhouse. Developed by Björn Strustrup, C++ offers direct hardware access, which makes it unbelievably fast and efficient. Plus, it's object-oriented, which basically allows for much better code organization as your projects get larger. And for sure, it is a gold standard in the industry, heavily relied upon by absolute tech giants like Google, NASA, and major game studios. To put that into perspective, learning this industry standard absolutely matters. From the high-octane graphics of Unreal Engine video games to the meticulous split-second calculations of banking software, where every single millisecond counts, C++ is everywhere. It's the backbone of operating systems. It's even the driving force behind embedded systems and AI robotics. By learning this, you're getting your hands on the exact same tools used to build the modern digital world. Which brings us nicely to Section 2, the logic of coding, or thinking like a machine. At the very heart of computer science is the algorithm. Now, to understand algorithms, you don't need a math degree. The syllabus uses this great, simple example of making coffee. An algorithm is literally just a procedure for solving a problem broken down into logical, sequential steps. Step 1, boil water. Step 2, add coffee. Step 3, pour water. Step 4, stir and serve. If you mix up those steps, like, say, pouring the water before you boil it, you're going to end up with a terrible, crunchy mess. Programming relies on this exact same sequential logic. And honestly, that simple, everyday logic translates perfectly into the professional program development cycle outlined in your PDF. You never just sit down and start typing blindly. First, you have analysis and design, understanding the problem and mapping out your algorithm. Only then do you actually move to coding. After that comes testing, debugging those inevitable errors, and finally, documenting and maintaining the software. Following this step-by-step cycle is really what separates a chaotic amateur from a true professional. All right, let's zoom in a bit for Section 3, syntax and data types. These are your fundamental building blocks. This right here is your visual anchor for the entire semester. Every single C++ program you write will start with this exact standard skeleton. You'll have your preprocessor directives like #include up at the top, which tells the computer what libraries to load, and then the beating heart of your program, the main function. Every single instruction you give the computer is going to live right inside the curly braces of that main function. But to actually write instructions inside that skeleton, you need a way to store information. And computers need to know exactly what kind of information they're looking at. Enter data types. If you're counting something whole, like students in a room, you use an int. Dealing with decimals, like a bank balance, you'll need a float or a double.
A char handles a single character, like a letter grade, while a string stores full text sequences. And finally, a bool just acts as a simple true or false switch. Trust me, categorizing your data correctly right from the start is absolutely crucial for keeping your code running smoothly. Finally, we've reached Section 4, Course Logistics, basically how you're actually going to pass CS 101. The PDF lays out a few straightforward but completely non-negotiable student responsibilities. First, you need to participate actively in coding sessions. You really can't learn to code just by watching someone else do it. You've got to submit all your activities on time. When you're in the lab, follow the rules strictly. That means absolutely no food or drinks anywhere near the equipment. And of course, always practice good digital citizenship. Now for the part everyone always jumps to, the grading breakdown. Notice where the emphasis lies here. Activities and labs carry the heaviest weight at a full 30%. Quizzes, major projects, and your examination are equally weighted at 20% each, with attendance rounding out that final 10%. So the grading structure is very explicitly designed to reward consistent, hands-on practice over just cramming for a test. And when it comes to laboratory integrity, the rule is incredibly simple. Write your own code. Avoid plagiarism. Never just copy answers from a classmate or grab something off the internet. As the syllabus wisely points out, the best way to learn to code is by coding. The struggle of staring at a broken program and finally figuring out how to fix it, that's exactly where the real learning happens. If you shortcut that process, you're honestly just shortchanging yourself. And remember, if you get stuck, contact your instructor via the portal. Seriously, don't just sit there in frustration, ask for help. Because the most important takeaway from this entire explainer is this. Every single expert programmer out there, the people programming rovers on Mars, the ones coding the next massive video game, they were all once beginners, sitting exactly where you are today. The machine is sitting there, waiting for your instructions. The only question left is, what are you going to build first?